Hey peeps, and welcome back to the channel. This is part 12 of the 3 Degree of Freedom motion simulator platform top frame build. Now, I don't know if you can hear this in the background. There's some clown running around out the front of my house with one of those backpack blowers. So anyway, hopefully it's not going to be bleeding through too much on the video. First thing to do today, guys, is to give everybody a big thumbs up for supporting my channel. Thanks to all those who have subscribed. And a quick reminder that if you're watching the channel for the first time, please, guys, hit that subscribe button and help support the doctor who's on his journey to help you. Now, guys, we can definitely tick off on our 140 by 140 20mm Merbau plate that the doctor measured up for taking the Fanatec shifter. So indeed, those measurements from Fanatec were correct. Why the doctor even bothered to doubt our beloved Fanatec, he will never know. So yes, those 90mm spacings and 70mm spacings that we put on the plate, the Fanatec screws straight into those. Here is the evidence. So that's great, guys. I'm going to put this on the rig now, and I'm going to tech screw this into position where I want it for me. This won't be permanent. Obviously, I'm champing at the bit to get my rig painted. Before I do that, we need to finish these few things. We're going to get these potentiometer brackets and our potentiometers on. Then, really, after that's done, I've got a few peripherals to chuck on from this new Fanatec gear. Got to hook up the computer, the monitor, and then, guys, we're going to run a test on this rig in its new top frame setup with the test electronics that the doctor already has set up. So that's our steps for today, at least to get the potentiometer set up. I probably won't get as far as into some game testing in this video, but definitely into the next one. So let's get this on the rig, see how it looks. Okay, peeps, so it's pretty straightforward. This is how the doctor's got his teched on, okay? So my 35 by 35 just teched into my 30 by 30 frame, and then my little adjuster here is teched in the front. Now, it's going to be a bit trickier getting the shifter 25 by 25 telescopic. It's going to be harder to get techs into that if we were to leave this on the frame, right? Because there's not a lot of space under there. So what I'd recommend is to take your old trusty Sharpie, hop down underneath, okay, and just mark where those techs come through. Okay, where the techs have got to drive through here, just mark on your 25 by 25 shifter mount plate. Right, then pre-tech those in a vise or whatever, and it's going to be much easier then to slide that in and then run your techs in that way. That's what I'd suggest you guys do to save a little bit of skin on your knuckles. Okay, peeps, this is the shifter on now. It's teched in, and I'm going to give you a little bit of a look at the end result here. So you can see there is a little bit of movement. Bit of flex on the shifter there, but I would hope that you weren't going to be abusing it quite as much as that. Look, it's accentuated by the fact that the whole frame's moving. Okay, that doesn't help. And obviously once there's some weight on the sim, you're sitting in it, etc., it's not going to be quite as wild, but mind you, it does get pretty wild. And the fact is, guys, that once you're in game, this thing's moving around a hell of a lot. So you're not going to notice that once you're in game. Anyway, I certainly wouldn't be too worried about that. That is a good little mount location there. There'll be no issues there. The doctor is very happy with that. Now, guys, just to reiterate and to remind you guys, be very careful driving your techs. Don't overdrive them. Otherwise, you will cook them and they will not be effective. Okay, follow the demonstration I gave you guys when we were doing the steering wheel frame, and make sure you're careful when you're driving them in. Okay, let's move on to our potentiometer mounting brackets. A few little quick measurements from the quack here have determined how we're going to need to set these up. Or this is one idea that the doctor has come up with for setting these potentiometer brackets up. The brackets that are going to carry our potentiometers. Now, obviously with my old rig, this was set up differently. So this is new territory for the doctor. But what we do need to do, guys, is we need to make sure that where our brackets live, okay, they can't come into contact with any of our motor connections here. These are the expensive Hall effect potentiometers. We don't want them to be damaged. So this means that for any of our bracketing, it needs to be away from potentially where this could come around and contact the bracket. Now, I think originally in materials needed and parts needed, I recommended a 65mm long M12 bolt. In retrospect, you can see here I have quite a lot of material protruding through my bracketing system here, which was fine on my old rig, didn't matter. But because I'm going to have to change the way the brackets sit on this, it would be advantageous to actually have these shorter. So you don't need 65mm long bolts if you haven't already purchased your bolts. A 55mm bolt will save you having to cut these off, which is what the doctor now has to do. Okay, so if the doctor brings his square here back to his motor lever, okay, the distance from the edge of our motor lever here, the outside face of the motor lever, to where your bolt is going to end here is just a little under 40mm. So to give ourselves a safety margin, we need to place our bracket 45mm away from this. So that gives us about 7mm clearance from where our bolt will be. So our bracket will be looking sort of something like this, if you can see that, which will allow any clearance issues if for some reason there's some malfunction with the software or with our electronics hardware and this starts running in a 360 degrees motion. Look, it'll be fun for us on the sim rig, but not so fun for our potentiometer brackets if we set them up too close. So that's what we have to do. Now, because everyone's setup is possibly going to slightly differ, it's probably better, guys, that we follow this through and do this together. Okay, so then you know what you need to do to set this up, because I would highly recommend that you actually go through the process of doing this rather than the quack just giving you guys the measurements, because if there's something off for some reason, it may not translate to your rig, okay? And so you could run into problems. So we need a baseline measurement, okay, for these brackets, and that is going to be based off the face of our motor lever here. So what we need to do, because the brackets are going to run off the main bracketing assembly here that carries our motors, we need to get a mark on this bracket. So you'll put a square on like this, run it to the face of your motor lever here. Okay, get it on there. And then mark on the main carrying bracket here, mark along this square. Okay, can you see that? All right, measure to the face, get a mark on there with its square, right? And then we know from that face of our motor lever there, we need a 45mm clearance. So then we can measure out 45mm from that line and we can mark that on our frame. Okay, that's going to give us our inside edge of our bracket. We cannot be any closer than that, all right? So that's the first measurement that you need to find. 45mm off the face of your motor lever. Okay, peeps, we're going to build these brackets from our faithful 30 by 30 by 2mm thick angle, okay? Now what you need to do is you need to cut two lengths of 60mm in length. Get them all cleaned up, nice and shiny like this, everything rounded off, everything nice, everything tactile, as the doctor always says. Okay, you will measure the halfway mark of your width, all right? Halfway mark is 15mm, make a mark, 15mm, make a mark, put a ruler on, draw a line. Then you're going to get the halfway mark of your length, which is 30mm. Make a mark, put your square on, draw a line. What we're going to do with this is we're going to slot. We're going to put a slot in to the halfway point we've just marked on our 60mm pieces. Now the way that I've done this is I used my trusty angle grinder with a grinding disc, which is 5 to 6mm in thickness. All right, and I just used it to basically burrow its way in. So it gives us about a 6mm gap, all right? Now, it'll be a little bit rough using this, as in the metal when you're finished. So you'll need to get a little file or something like that. And then in the very end here, you'll need to just clean that up a little bit. Clean right along, clean the back. Make sure that all the burrs and stuff like that have been removed and it's nice and smooth. Now, the other thing to remember, guys, you need to locate them like this, in this orientation, okay? So then if you put your two pieces together like this, the slots were in the top. Okay, that's probably the best way for me to describe to you where to put the slots. Don't put one up here and one down the bottom. They both need to be in the top, and the angle has to be located like this. So if you put them together like that, your slots are in the top. Okay, to get our little 60mm slotted brackets in place here, guys, we just need to make sure that where we marked our mark on the top of our motor carrying bracket here at 45mm, put your square on that. Okay, and then do the same, mark 45 at the 45mm mark there down the face. Okay, so when we put our bracket on here, we can get it square with our line. Now you need to do that measurement, or how we did this side, guys, with our square off the face of our motor lever, etc. You need to do that both sides, okay, and get that set up. It should be the same. You should have a mark ultimately 45mm in from your mark that is found at the face of your motor lever. So you'll just repeat exactly what we did on this side on the other side. Okay, guys, we need to get these slotted 30x30 angles on our main motor mount carry bracket here. And this is how you're going to orientate them, okay? So here's our motor, all right? Here's our bracket with the slot facing the motor, all right? Now, where we drew our line earlier at that 45mm mark, right, this is how you're going to line that up down along that line so you can get it square. Now, just do a dummy fit, guys, and then with your Sharpie, mark around this, right, so you know where you're going to have to weld it. Take it away and then clean the primer off this bracket, ready to tack. We'll only be tacking this on the vertical, 2 tacks, and then 2 tacks across the back here. Our potentiometers don't need to carry any major weight. They just sit there. So we don't have to go crazy welding this. Just 4 tacks in total will be more than enough. Now, as you can see, the bracket sits proud off the top of the main motor mount bracket. It sits 25mm above. So from the top of your bracket down to the top here on our motor mount carry bracket here is 25mm. And that's how you'll locate it, and that's how you'll tack it on your inboard 45mm mark. Now, what the doctor is going to use to connect across to his potentiometer. But maybe before we get to that, what's going to greatly assist you guys is if you actually install your motor to potentiometer tube. Now, if you've got no idea what I'm talking about here, then you must watch the potentiometer to motor shaft video that has all the components that you need in that video and the steps you have to take to drill your shaft and tap your shaft and place your M4 0.7 thread pitch furniture screw to run this tube on. So please refer to that video so then you know what you need to do to get to this step. So we'll be placing this on because that will help us work out distance for our cross bracket here that will house our potentiometer. Now, as it turns out, the doctor has ended up using more or less the same bracketing that he used on his old rig, except it was like this. On my old rig, I had some 90s that the potentiometer came through, okay, and I've just flattened that out in the vise. Now, it's stressed it a bit because it was a 90. I've just got to run some weld in here to strengthen this up, but I believe if you're an Australian watching this video, this modular bracketing stuff is just bought from Bunnings, okay? And this is just 20mm wide. It's 150mm in length and it's 2mm thick. So if you're not in Australia and you can't access this type of material, just some flat steel, 20mm wide, cut at 150 long will get you out of trouble. You will just need to measure from one end, let's call this the left-hand side, you'll just have to measure in 37 millimeters. So you'll find the center of this first, which will be 10 millimeters. Mark a center along there, then measure in from this end 37 millimeters and make a mark, punch it and drill a hole. That is a 10 millimeter in diameter hole, okay? Now what I'll be doing is I'll actually be putting my angle grinder on this now and making a slot. So then we've got even more flexibility to align our potentiometer. And what we're about to do next, guys, this is where it really pays to hang on to some of your really short used cutting discs, because this will just make it a lot easier to cut this slot in this metal without making the slots too large. So always hang on to at least one of your used pieces of cut-off discs, because they're handy if you ever need to do any slotting. So that's just a tip from the doctor to you. Okay, let me take you through this convoluted and quite painful process that I just went through to get some brackets sorted out for these potentiometer connections, okay? So this was the original piece that I had, okay? This needs to convert into this, basically, okay? So what I've done is where my 10 millimeter hole is here, right? I've slotted that out with my angle grinder. It had to be this large because even with the smallest angle grinder disc, you still end up with a slot at a similar length to that, okay? Almost covers two of these little modular nodes here, right? Then I've needed to extend one end of it to pick up two bolts in our slot so then we don't get any of this. So to do that, I cut the end off that was unneeded, okay? I ground it down because it was too wide. So I ground quite a little bit off it, closer to the hole, and then I've welded it on the end. So then basically, when it sits in our slot here, it allows two bolts, right, in the slot, so it can't do this. And as you can see, that pretty much lines up as it is with the potentiometer, where the potentiometer is going to go through there, and there's enough slotting on that to give us a little bit of flexibility. And what I ended up having to do as well, guys, is I've ended up having to take some more material out of the slot. So originally where it came down to the 30 millimeter mark, I've dropped that probably down another 10 millimeters. I've gone another 10 millimeters beyond the 30 millimeter mark on that other angle. I'm about to do the same here. So I'll take this down further. I'll take this slot this way, probably another 10 mil to allow that width here to get both bolts in that slot. Okay, and then I just had to go through my vast array of bits and pieces of nuts and bolts to find some little bolts that will come through. So what I'll do is these guys, right, when they go through here, I'll actually tack weld these on. So then they're permanently on there. So then that just goes through the slot, and it's just much easier then to do a nut up to the slot rather than having a hole both ends. So once I've put these through, I will tack weld this. Then when it comes in and sits in the slot, it's easy just to put a nut on the other side with a washer and do it up. So anyway, guys, that's what I've done using this type of modular bracketing, okay? If you're just using straight flat, I mean, you may have to do something similar. You might have to add a little bit at the bottom because you do need two bolts, so then you don't get the movement. Otherwise, it'll pivot on one bolt, and you don't want that, okay? Because you want as accurate readings from your potentiometer back to the Arduino as possible for your sim experience. So we need to, even though this doesn't need heaps of strength or brute force in it, it does need to remain rigid. So then those potentiometers only send the information from them turning, no other unnecessary movement from the actual bracketing. That's basically it in a nutshell, guys. You will need to basically fiddle around. The most important measurement is that 10 millimeter hole. That's the hole diameter you need for those hall sensor potentiometers that are in the links. Okay, they fit through a 10 millimeter hole. So I'm going to put this on now, and then I'm going to put my potentiometer through this and in to the motor bracket so you can see it all set up. It's worth mentioning, guys, when you get that material slotted, it's handy to have just a little flat file like this. It's a very narrow diameter. It's about a 10mm diameter little steel file, and it's just handy to be able to file nice and smooth your slotted area, because when you cut it with your angle grinder, it'll be quite jagged and quite harsh. So you'll need to file it and smooth it down. A little file like that works really well for that type of scenario. Okay, the doctor felt guilty, guys, because he didn't really show you what he did, okay? So look, this is all I've done, right? So where that 10mm mark, where that 10mm hole is on the end, right? I've cut that piece off the end, which was on the end, because that's going to go down here. I'm going to have to grind some material off this first, because otherwise it's too wide for the slot. So I'll grind that down probably 5mm in total, and then it'll be welded onto there, okay? Here, I just ran my angle grinder along, and it's at the very end here that's the most important part that we want to take out. We don't want to blow all the way through, so you have to be careful towards the end, but you'll need a slot that size because of the angle grinder disc. Even with those small discs, by the time you get in deep enough to get these slots in towards the end here, it'll end up being like this. So I'll get my screwdriver in this now, I'll pry that up, I'll cut it off, then I'll get that little file, okay? I'll get my little file here, and I'll file this part along the end here all the way flat, which is what I did on this one. Okay, you can see the slots on that one almost came all the way through. I've just filed that down. And ignore this welding, guys. Remember, these were a 90 bracket for me. And when I bent these back, of course, it fatigues the metal when you bend them back. And so I needed to put those welds in to make sure that they didn't fail. Okay, that's what the story is with these welds in those locations, is because that's where this was bent at a 90-degree angle previously. If you just get a flat steel, you won't have any welding or anything needing to happen on these other than extending the bottoms here. So you can see there's the screws. I've just tack welded them in, so then that just makes that much easier to attach to our slot. So that's what's happening with what I've done with these, and it will be similar with you guys, either if you get these modular brackets from Bunnings if you're here in Australia, or if Walmart has something like this in the States, or I'm not sure what you guys in Europe would have equivalent to this. I'm sure you do. These Chinese companies must have this product all over the world. Or you can just use some flat steel in the dimensions that I've already mentioned. Well, that was a bit of a marathon, guys, but it's all on. The potentiometers are on. That's the finished product, doing it this way, okay? It still gives us the flex we want in our hose to allow any indiscrepancies between our motor shaft and our potentiometer connection. So, guys, as always, you know, this was a Dr. ADHD special as far as just coming up with something that works. If you've got a way of doing that that's easier, I'd say shoot for that one and do it. Otherwise, this is a way to do it, and it certainly works without any issues there. When you do this, you basically need to have your potentiometer in the bracket first, and you need to have your hose on the potentiometer first. And then you bring the whole bracket onto the connecting point in your shaft here. Okay, so you put your potentiometer, well, you put your hose clamps on the hose first, not tightened obviously. Then slide your potentiometer through your bracket here, nip it up on the other side with the nut, then put your hose on it, and then you bring the whole assembly with the hose hanging off it into alignment, and then slide that hose onto your connection here into your motor shaft. Then you can do these up. And that's the way to do it, guys. Now, I think the doctor's getting a bit of COVID, because my wife's just had COVID, and you can hear my voice is starting to fail here, and I've got a bit of a sore throat. So I reckon it's COVID city for the doctor. Oh, the joys of COVID. This is round 2 for the quack with COVID. Last one wasn't too bad, but this one I'm a little bit worried about because I didn't get a sore throat last time. I might have the nasty one. Anyway, guys, this is the doctor signing out, and we'll see you in part 13. Button box and all the peripherals set up on the rig. Just wanted to say, guys, stay safe, stay healthy, don't get COVID, and take it easy out there.